Okay, in this video we're going to go over the 4.5 notes, proving triangles congruent by SAS and HL. So we've already done side, side, side. So here are two more ways to prove triangles congruent. So by definition, in a right triangle, the sides adjacent to the right angle are called the legs, and the hypotenuse is the side opposite the right angle is called the hypotenuse. So look at this little sketch. Here's a triangle. So here's the hypotenuse, and here's a leg, and here's a leg. And you pretty much knew that already, but I have it here explicitly for you. Okay, so here's our postulate. If two sides and the included angle, so here is a side, here is a side, here is the angle that's included between them. Here's a side, here's a side, here is the angle included between them. So if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So what they're saying is, if you have RS equals UV, those are the sides, the included angle is between those two sides that are going to be mentioned. So that's angle R and angle U, and then the other side is RT and UW. So think of it as the angle sandwiched between two sides. So the angle is the jelly and the sides are the bread. Okay, so let's write out this postulate ourselves. So what we want to know is, if we are going to prove two triangles are congruent by side angle side, that only works if two sides and the included angle, okay, that word is key. It's not any angle, it's the included angle of one triangle are congruent to two sides and the included angle of a second triangle. Then the two triangles are indeed congruent. Okay, so, and here is your more information about right triangles. This is exactly what I did for you right there. Okay, let's go on to the next page. Okay, here's another way to prove triangles congruent. It's called the HL congruence. Okay, the H stands for hypotenuse and the L stands for leg. And this only works if you have a right triangle. Okay, must have the right triangle in order to use HL. So let's look at this theorem. We're going to fill in these pieces for ourselves. If the hypotenuse and a leg of a right triangle, okay, it has to be a right triangle, are congruent to the hypotenuse and a leg of a second right triangle, then the two triangles are congruent. Okay, let's try some practice. Okay, so first off, they want you to separate this sketch right here into two triangles side by side with corresponding parts in the same position. Okay, so I'm going to first draw the triangle to the right. That is CBD. Then I'm going to draw the other triangle that was to the left and upside down this way. Okay, where is my right angle? It's at B. And if I had flipped that over, C would have been on the top and A would have been here. So these are the angles that are congruent. AC equals BD. I have a right triangle, and what do you say about this and this? That is equal to itself by the reflexive property, and when you separate it out, you are allowed to indicate that they're equal because it is basically the same piece, right? So this is the reflexive property right here. This is what we're using. So now I have these two triangles drawn side by side like this, and what they want me to do now is to prove that ACB is congruent to DBC. So how would I go about proving that? So what I would say is the following. I would say that angle B equals angle C because right angles are equal. Okay, here's an angle then. Then I would say CB equals BC because of the reflexive property. Same equals same, self equals self. Okay, then I'm going to work up here. Then I would also say that CA is congruent to BD, and why is that true? Because it was given to us. So based on these three things, side, angle, side, excuse me, I'm losing my head here, hold on. So because of these two things, we have a right triangle, and we have what? CA and BD is the hypotenuse, and CB and BC is a leg. So because of HL, you can now prove that they are congruent. So by HL, I have proven that triangle, we'll do their order, ACB is congruent to triangle DBC. Okay, so let me look at the homework with you for a second. Next page. Okay, so you're going to do this homework. It says, see if you can use SAS or HL to prove, and this should say, these triangles congruent. If so, add letters to the vertices and write a congruence statement. If not, state not enough information. So let's do the first couple together. Okay, looking at one, I can see that this is a reflexive piece. It's the same piece in both triangles, so same equals same. It looks like I have side, angle, side. So I'm going to say I can prove it by side, angle, side. We are now going to label the triangle. The top is ACB, and I went one and then down the common. So that's going to be congruent to go up and then down the common. So that's CBD, and I proved it by side, angle, side. Okay, look at this next one. This is set up for side, angle, side, but look at this one. Side, oops, I don't have the angle that's included, so this is a no. Okay, and I'm going to do 3 and 4. So 3, look at 3. Do you see how this is the included, or this is a reflexive piece, that it's the same in both triangles? So therefore, I can say that they are congruent by side, angle, side. So let's go A, B, C, D. So if I go down 1 and then down the common, that's A, C, D is congruent to triangle. So I have to go down the 1 and then down the common. C, D, B. C, D, B. Let me make one thing certain. This little mark right here was the triangle, not a letter D, and this was A, C, D. Okay, one more, because I want to check out the HL. Look at this common side. That common side is the hypotenuse. I have the right angles, and I have a hypotenuse and a leg. So by HL, I can prove that these two triangles are congruent. Let me just label them. So if I call the first one triangle ABC, I'm going to have to call the second one, let's see. I went down the blank side and then across the 2. So down the blank, AD, and then up the 2, C. Okay, and that's by HL. Okay, you should be able to do the rest of them. You're only going to be using SAS or HL or not enough info. If you find that you can prove by HL or SAS, you also need to go ahead and label the triangles and write the congruency statements. Okay, that's what these are. These are congruency statements. So this is what you want to do. Okay? All right, so you're on your own. Go ahead and work on this.